Welcome to the first bootcamp. Today we'll focus on a book called How to Be a Modern Scientist, which is not as technical as you would expect, but I think it's gonna help us frame our ideas and why we're doing things the way we do things. And it's just really gonna be like a solid foundation for the philosophy that we'll try to follow. So let me get ready to share my screen. So I'll send you a link on Slack for the course, for the where I have things, not the course, but okay. And then also the slides that I'll be using today. Sorry, I don't know if I said Slack, I meant Zoom. That's why I'm sending the links. All right, so let's get started. So this is the first bootcamp. And we're recording this because either other people at Lever or outside of Lever might be interested in this, and hopefully we'll have new people also join the team in the future. And so really the idea of today is to go over this book, why, and explain why I think it could be useful for all of us. And so I'm building this website called BioC_team_DS, my profile on GitHub, which are the links that I sent you on Slack. But in particular, this book is completely available through LeanPub, and we'll spend some time setting this up. And it was made by Jeff Leake. Okay, so Jeffrey T. Leake wrote this book, and it was last updated on April of 2016. And it's a very short book, 82 pages, depending on the length of your pages, and it has around 31,000 readers. So we will just add to that tally a little bit. And so this is a book where Jeff has compiled ideas that he had over years from himself and other people about how to be a scientist the modern open source way, right? And so you already know that we make a lot of our code public through GitHub and things like that. And so that's part of the set of tools, but we've never actually explained the framework. So this book will go over that. And so this book is based on blog posts that Jeff wrote on the Simple Statistics blog. This was started in 2011, still active, but not as much as it used to be. And this is a blog with 3 different faculty members. Jeff himself, then Roger Peng from Hopkins Biostatistics, and Rafael Irizarry, who was at Hopkins and now is at Harvard, and also Dana-Farber Cancer, the Dana-Farber Cancer Institute. And so this blog became quite popular and it's widely accessed. And Jeff wanted to organize his ideas that he had over the years into a more concise format and more coherent. And so that's how this book came to be. Now, on this link, leanpub.com/modern scientist, you can buy the book. And I'm putting buy on italics or with quotes. Because LeanPub, the way it works is it's a publishing platform that gives 80% of the royalties back to the authors. And in this case, actually, Jeff chose to earn 50% of those royalties himself, and then 50% go to a specific cost. I don't actually remember what is the cost. And LeanPub allows authors to set a minimum price and a suggested price and a maximum price. And so in this particular case, this book the suggested price is $10, but you can actually go down to 0 and basically get it for free. And so that's why I chose this book and other resources, because you can either get them for a very accessible price, or you can just get them for free. And Jeff and others really believe that this is the way that this is a great way to try to reach as many people. And so some people might not have any resources at all. Some of them might have more, right? And so, or maybe some people just want to try it out, and then if they like it, maybe give some money, right? So this is really up to you. What I want you to do is to actually make a LeanPub account. So access leanpub.com/scientist, and then buy the book as you can buy for $0 right now. And once you do, let me open that link myself. Once you do, you'll notice that there's many different ways of reading the book. You can read it as a PDF, as a MOBI file, which is the file format used for Amazon Kindle, or you can simply read it on the web. So here on my profile, I'm going to go to my library. I can see the books that I've purchased over the years. And so when I look here at how to be a modern scientist, and so there's there's many different ways here. One of them is simply downloading the PDF. So I spent a bit of time on that, doing that. And so let me know. Zoom has, if you go under participants, you can click a yes or a no button, a green or a no button. So can you let me know whenever you have access to the book? Right. So now that everyone bought the book, right, for free potentially, you can then read it in multiple ways. And so there's a LeanPub and Kindle connection, which I spent quite a bit of time learning how to do. But maybe you don't want to do this. And so I'm saying that maybe you don't want to do it because, for example, I read it on my Kindle, highlighted stuff on my Kindle, and then I cannot see my notes on my computer. So that's why I have a little sad face. So you might actually want to just simply directly download it as a PDF. But if you actually want to do this as a Kindle, on your Amazon account, there's something called the Manage Your Content and Devices tab. Under that, there's the Preference section. And then there's another one called Personal Document Settings. And there you have to add to your approved personal document email list the hello@leanpub.com email address. And so like this link over here at Lean has all those instructions. But actually, some of this stuff didn't actually work for me. So what I ended up doing is that you can actually download from LeanPub what's called the MOBI file, MOBI. And then you can email it manually to your Kindle address. So this book, like you can definitely read it on a Kindle. You don't need to read it on your computer, but you might want to simply read it as a PDF. Okay, so I'm going to assume that most of you are just going to either read it on the website or on a PDF for now. So the table of contents, there's quite a bit here, right? I mean, there's an introduction and about the author, but in between of that, there's like around 10 or so chapters: paper writing, publishing, peer review, data sharing, scientific blogging, scientific code, social media and science, teaching in science, books, internal scientific communication, scientific talks, reading scientific papers, credit, career planning, and your online. So that's quite a bit of of things to care about or to read more on. And so in the website I am building, like I wrote a little like overview about this book, and that's basically what I'm mentioning in slide format right now. But I also wanted you to think about how many chapters, like I mean, if you exclude the introduction and the table of contents and the about the author sections, how many chapters do you think currently apply to you? And that might be different from the next question, which is like, how many of them are you interested in, right? So let me pause the recording so you can think a bit more about this. Okay. I thought I had learned the keyboard shortcut for resuming and pausing, but maybe it didn't. Okay, so we just discussed what some of you are interested in, and you could always like rotate in 90 degrees, and I feel like these are like toggles, right? And so everyone has a different profile, right? Some of us try to maximize some of these points. Some of us are just like, I want to know a little bit about it, and sometimes there might be things that we're like, I don't really care about this, right? And so we're all a bit different, but I do agree that that a lot of these topics actually apply to us. And something that's actually quite important or useful from this book is that it gives us a framework to think about each of these different important topics. And so this can be like a launching pad. So like, let's say you want to make a Twitter account and tweet about science. There are some important thoughts on this chapter that are very useful to know before maybe you start actually making your before you decide to make a social account for science, or like techniques about reading papers and stuff. And so why this book? The target audience of this book, when Jeff wrote it, he had academics in mind, so graduate students, postdocs, and like PIs, right? And so most of you are actually not graduate students or postdocs right now, and like, I mean, people seeing this video in the future, they might be, but overall, like where we work, Libre Institute for Brain Development is an industry academia hybrid. So we should actually be reading some papers in software, right? So, and that's something that I personally need to do a better job of reading about what's going on in the world. But as an institute and like as a team, we're definitely involved in publishing papers, presenting results, sharing data, sharing code, and many of the other chapter titles that we just saw. So individually, maybe some people do more code and generate more data than actually write papers or present results, although everyone has the option to do that, right? And another thing of why this book is we actually do work with a lot of the target audience for the book, right? We do work quite a bit with like academics. And so as part of what we'll be doing on the data science guidance sessions, we'll actually guide like students and postdocs, right? And so knowing what they're going to go through or things that could be useful for them is also useful for us, right, as guides in that sense. And so basically, this is the same theme that I've been saying that has motivated all the boot camps, which is like having a common referral source will be useful. And then like also why this book? Well, Jeff was my PhD advisor, and I've been learning about this way of life for a while, this way of thinking. And actually, some of the things he says you shouldn't do, it's probably because I made them. So like I've definitely made mistakes along the way, right? And Jeff is very thoughtful about his advice and definitely less confrontational than sometimes other people are. And so that is a very good way of living your academic life or your scientific life. So I like a lot of how Jeff thinks. Now, also like talking with you guys right now, I like the book, knowing all the different sections of the book can be useful because sometimes there's a concept that you're interested in learning, but you don't actually have a name for the concept, right? And so here we actually get like specific bullets, right, for each of the different components of being a scientist that we might care about, right? And so the bootcamp won't be long enough for this, but definitely like the next, we have a lot of time together, such that like I can teach you about these things if there's a particular subject that you want to learn more on beyond what's on the book, right? And then like if we go back to this image of like the toggles, right? So if you want to learn more about something, I can guide you in that area more. Okay, so that's on the book. So let's look at the introduction. So each of these chapters, Jeff tries to answer 3 different questions for each of the chapters. One of them is what should I do? Why should I be doing this, right? So why should I be reading papers? Then the next bullet, he tries to answer the next question is what tools should I use, right? And so Jeff tries to use like open source tools or free to access tools most of the time. Some of them do require subscriptions, some of the ones he suggests them. And then for each chapter, he might have like more advanced tips or like concerns about how to take it from there. Now note that this book was last updated in 2016, so we might be using newer tools than the ones listed on the book. Or maybe it's because I like other software than Jeff, right? So that's the framework of this book. And in the overview that I presented, I actually like parts of the website that I'm building are based on these chapters or expand my thoughts on the chapters. So for example, there's a chapter on career planning. And so there's a chapter on the how to be a modern scientist book on career planning. And that led to the career growth chapter on the website that I'm working on, right? And so the career planning chapter by Jeff is longer and goes in more detail. It mentions, for example, a list of questions adapted from Ben Langmead. And I distilled that information and made it shorter for you guys. And so between this week and the beginning of next week, I'll be meeting with all of you to have some career planning sessions. All the people in the team. There's 2 chapters on scientific reading, like writing and then presentations. And so we'll actually apply this in the weekly meetings that we'll have on the section on papers and software. So these will provide us a training ground on for us to practice these concepts on the book, and it's going to evolve over time. Right? So let me pause. I didn't pause. All right. So what I'll do now is I'll dive a bit into the book. This is a PDF version that I have, and I read it on my Kindle, so I don't have my notes highlighted here, which is what I wanted to show you. But the idea of what I'm going to try to do in the next minutes is to just give you an overview of what this book has. So paper writing here, this is a chapter I would actually recommend maybe reading later on, because it's like, oh, you should like share your code, you should like have nice figures and stuff. And this is like, some of that stuff is explained in the latter chapters. But one of them is, if you're writing a book, a paper, the main thing is to make the figures the focus of what you're writing. And so at some point he's like, how do you actually write? So, okay, I'll get back to that, sorry. So I actually like this description from Jeff quite a bit about like what is an academic paper. So it is like, either you have some methods that you're describing, some data that you're showing, some results, or some claims that you want to advance. And so the claims, that's the hardest part, right? And like potentially this is something that like our biological collaborators might spend more time on, or the let's say the graduate student or the postdoc leading some of the papers, or whoever has to spend a lot of time thinking about what the results will mean, right? It's probably going to write that section. And all of us will at least like write some of the methods or describe some of the data results, right, in different projects. So those are the four like main components of a paper. And so one question that Jeff explores is, when do you start writing a paper? And one of them, this is like really tricky, because this is when you have enough information, then it's like at that point, that's a perfect time to start writing a paper, or a great time to start writing a paper. And there's this thing about the perfect is the enemy of the very good, or the good. And that happens a lot to us. Sometimes you want to just have the best paper out there, but it might take you a very long time to write that paper. And then like you might realize that like there's no perfect solution or no perfect paper. Right. So Jeff explores the question of, how do you actually start writing? And so this is where we come back to the figures. And this is actually something we do quite a bit, which is you first want to have the figures that you're going to show. So you want to have like 1 to 4 quality plots. And each of those plots actually might have multiple subplots. So like in a lot of the projects we're working actually on the figures first. So you might not actually be seeing a paper in your mind, but like we're already thinking of like, what are the figures we want to show? For example, we might have like a supplementary figure about how some of the samples we selected were chosen, right? And so actually some of you you're in a phase of a project where you're doing that, right? And so the way I'm viewing it those is like, okay, we have our figure that's going to show that particular step of the process, right? So now let's show let's get the next step of our story out there, and that is really figure focused, and that's going to be directly related to our reading scientific papers chapter. Then there's more details about like what is actually involved in a paper, and there's a lot of pieces here, like the title, abstract, introduction, methods, analysis, and stuff like that. And a paper is quite a bit of work, right? And so some of the latter chapters are directly involved with like specific parts of it. For example, like data sharing is actually part of the methods, where you describe where is the data, right? And so we'll get to that part. Then there's other sections here that are like maybe less of less interest to right now, which is the publishing chapter. Why is that? That's because we already have a defined system of how we do stuff, right? And we like to post preprints, and that is a great way of advancing science. There's also very good reasons why you should post preprints, because it helps junior members in the team, right, and get some of that credit at an earlier phase, and that can enable them to advance their careers faster. But a lot of this publishing chapter is about convincing people to post preprints, why it's useful for you. Also highlight maybe potentially some of the drawbacks about it. So this publishing chapter like is good if you're curious about like what is the philosophy of how we chose to do things, but it's not something we're actually going to change much, right? Because we're already posting preprints and stuff like that. Peer review. So This is also one of the chapters that applies less to you guys right now, because this is when people ask you to check someone else's papers. Now, it will apply to us in the sense that we will send our manuscripts, our papers, to be reviewed by others, and they'll respond to us, right, what they thought about our work, and then we will need to respond to the criticism. And so let me see. There's a phrase here that I'm trying to find. I don't have it highlighted here. Anyway, but like the phrase that, or the statement that I want to highlight from Jeff is like, whenever you get comments from others, you might be tempted to respond to their criticism, to argue why their criticism is incorrect or doesn't apply to the current case. And that is a trap, because you might feel too tempted to respond in a personal way. And instead, maybe it's on the peer review here. Instead, you should try to be calm. Try not to engage in a direct discussion with the reviewer, because if you try to make it personal, you're actually going to lose that argument. And so you need a lot of patience for that. Okay, peer review. So I forgot where that was. Okay, let's look into data sharing. So data sharing is something we do, but we could actually do better, right? And so Jeff here argues that the question of reproducibility isn't if anymore, it's how, right? And so people have been advocating for a while that you actually need to share data if you want your analysis to be reproduced. The problem is we don't have actually as a field, we don't have very well defined standards of how to share this. And so there's a lot of room open to interpretation, right? And we're trying to do a good job, but we potentially could be doing a better job. And so the data, you have to make it public. So you can post it on a public repository. But the thing that we're not doing a great job sometimes is organizing and documenting our data. And so this involves actually two things. We should post the raw data. So this is the data that hasn't, like, for example, the data that we get from sequencing team at Liber, led by Johan, like all the FASTQ files, let's say, for our RNA-seq project. But we should also be sharing the tidy versions of our data. And so these are for example, the clean range summarized experiment objects that, let's say, someone like Luis or Josh created, right? So this is something we do. We do share the raw data and the tidy versions of our data. However, something that we don't always do a great job of is explaining exactly all the steps in that data. So all the covariates that we have, what they actually mean, because we work with complicated covariates, right? And so sometimes here, what is really good is to make a code book explaining every single variable that is, for example, in the cold data slot of our range summarized experiment object. But is this something that we haven't done a great job of? And why is that? This is because, like, a lot of times in the process of a project, this is relegated towards the end. And at the end, like, you just want to get done. You just want to be done with the project. And it's actually sometimes better to do it earlier on, because that information might be useful for new team members that join the project, and is going to be helping analyze that data. And we also post all the relevant code. However, sometimes our code is a little bit messy and is not as well organized. So there's a lot of stuff here that we need to sometimes improve. So let's see. There's this whole section on the book based on an editorial posted on the New England Journal of Medicine, which was about data sharing. And the editor there used the term research parasite as a negative term. And Jeff explains a lot about why this was not a good editorial and what his concerns are with it. But I just wanted to mention it because there's actually the Research Parasite Awards that were created because of that editorial. And Rafael Irizarry actually won it in 2019. He won that award. And these are people in our field that were like, oh, you think a research parasite is a bad thing? Actually, that's a great thing. Those are the people that are making it easier they're reusing data in that other people have published and without them, like science wouldn't be advancing as much. So that's the research parasite, and there's also the research symbiont, which I'm a part of their committee. That's because I got one of the awards also in 2019. So if you hear about those terms, research symbiont or research parasite, reading that chapter of Jeff's book will be quite useful to understanding what are all the issues with it. Okay. So data sharing is something that we need to do a better job of organizing our code and all of that and our data. And so there's actually a chapter in scientific code that it will explain more of that in a bit. Scientific blogging. So as far as I know, none of you have a blog post or a blog website. Is that right? Yeah. Okay. Well, I do. I love scientific blogging. I don't actually spend as much time on it as I did maybe in the past. But Jeff has multiple reasons to mention scientific blogging. And so he says, like, there are many reasons why you want to do it. One of them is to respond to criticism. That's actually not a reason why I blog at all. I rarely respond to, well, I guess I've gotten a lot of criticism in the past, but I haven't used this version of a blog in the past mostly. Maybe a little bit here or there. Another one is for raising your profile. And so this is a big reason why I like to blog. And so on a blog, you have control of how you want to explain things. And it allows you, for example, to explain the results of a paper in a less technical way. And that could be quite useful. You want to explain the results of your work for a broader audience. I like writing blogs also because a blog post as a reminder to myself of how I solved a specific problem. And I'm not a native English speaker, so writing blog posts helps me practice writing in English and explaining my ideas and thoughts to others. And so those are reasons why I like to blog. But like for you guys and everyone, like Jeff here highlights some other points of why it can be important. So maybe you want to practice your storytelling or your communication skills. Or maybe you have some great data visualizations that you want to share, or teach people how to do something, or discuss something that is important to the industry. And so all those reasons are one great motivation for practicing all of this is that all these skills are like highly valued in our field, right? And so if you're a great storyteller or communicator, there's a lot of great jobs in data science that rely on having good communication skills. If you have like a great data visualization skills, that's also really good because like that's basically what we do, right? We make plots, right? If you're great at teaching, that's also gonna be of interest to others that want to hire data scientists that can explain all the complicated concepts to the rest of their teams, right? To the rest of their scientific teams. And so this is like translating knowledge, right? And so this 3 bullets, right? Like it's important to practice them. And so a couple of years ago, I created a blog that all of you are welcome to contribute to, which is LIBD RStats Club website. And so you don't actually have to spend as much time dealing with the technology and how to set up that blog. But I just want to invite all of you to, if you have ideas, or if you simply want to practice your skills in these areas, right? And that's a great venue. And so on the website that I'm building, there's a section on how to contribute. And so that's where I'll explain how to contribute to the LIBD RStats Club website. And so other people in the past in Andrew's team have actually written blog posts. And for example, former master's student, Amy Peterson, wrote a blog post, and like that, having that blog and other things helped her to secure a job as a data scientist in New York. And so this will be part of the career advancement. And so scientific blogging, scientific communication is a great way to get your name out there. And so we don't want to actually talk about the tools because the tools that I like to use are different from all of the ones that Jeff mentioned for writing blog posts. And then he gets more into details about like dealing with criticism, and if someone criticizes a paper of yours and you want to respond on a blog post. But that actually doesn't really apply to us because we don't have experiences like that, like he had. Okay, scientific code. So we already write code, right? And I've been teaching all of you to use GitHub to share your code through a public repository. So this is something I highly value, and some of the things that we are working on are on organizing and documenting our code, right? So for example, for the organizing section, we've been learning about the recent tool called the Here package, right? How that can help us to organize our code. Then we're going to learn about building software too, so building our packages, and that's going to be helpful for sharing more of our code, and maybe also even getting our code to a higher level of standard, such that it can be admitted onto like a website like Bioconductor, for example. So GitHub is central for everything we do with code, and Bioconductor, because we work with a lot of genomic software, is also central to us. But some of you, like let's say Maddie, who's working more in imaging analysis, might be more interested in like CRAN, rOpenSci, or something that's called Neuroconductor, that's made by one of our friends. Okay, so we'll be sharing code, we'll be sharing scripts, and we might also be sharing something that's called literate programming. And so that name might be unknown to you. The name that is more commonly known for you guys is R Markdown, right? So this is Quine or Jupyter Notebooks. So these are files that contain both text and the code output. They take longer to make than regular R scripts than regular R scripts, but they have a lot of advantages, and they guarantee a higher level of reproducibility than a simple R script. However, sometimes we don't have all the time to make our markdowns, right? Because you need to fully test them before you can compile them. And so for some projects, we actually do rely on literate programming. So for example, on the new Speakeasy project, several of you have worked on literate documents as a way of sharing our code. Now, this is a great quote from Carl Broman, who's faculty at University of Wisconsin. And like one of the great reasons of why we want to document our code is because your closest collaborator is you 6 months ago, but you don't respond to the emails anymore. So that's a great quote. And that will happen to us. And so some of you have already been experienced this, like where you're like, oh, like you look at code from a couple of months ago, you're like, I don't know what I was thinking here. And that's why like we use also GitHub, and why I highly recommend everyone to use verbose Git commit messages, right? So just that we can remember what we were thinking a couple weeks or months ago. And like, I mean, the session information is always useful. We always include that. All right. Once we start building code, we need to document it. But this is something that I'll skip a bit, because this is something we'll address more on the Building Tidy Tools workshop. How we can document things, like help files and also vignettes and things like that. Cool. Let me move on to social media and science. So social media and science here, first Jeff asks, like, why should you do it, and why is it relevant? And so one reason is you want to promote work of other people, right? So this is actually like a reason I would love if you had Twitter accounts, because then I can also promote you guys. But I understand that there's strong reasons why sometimes people don't want to make a social media account in science. But let's say you have an account. This makes it easier for me to highlight all of you and to give, to make it easier for other people to find you, right? And potentially get in touch with you, and maybe make you job offers or things like that, right, in the future. That's one way. Let's say you're reading papers, right, or you're interested in software. A social media account for science can also be a great way to find those papers, software, or people that are people you might be interested in connecting with, or that simply share the papers they thought were interested in. And so that's actually related to using the social media account to promote the work of other people, because those people are being content creators. And so maybe you just want to follow like good content creators. They also might be funny, and so, or you might think that they're interesting. So having a social media account is a great way to follow those people. There's a lot of people that have a social media account, without any tweets at all, like a Twitter account without any tweets at all, but they're just following people, right? They're just feeding on the content other people share, right? I do this a lot, which is sharing the work that you do, right? And so this is also where, like, if there's people in the team that have Twitter accounts, then I can directly highlight them on Twitter. Right? Jeff goes into a bit of Twitter versus Facebook and their uses. For us, it's really just Twitter. In Mexico, people use Facebook a lot for science, but that's, I don't think, as much the case here. There's more tips here that Jeff gives. For example, you might not need to develop your own content. You can always be sharing content from others. There's people that have become really good at sharing content from others, and one of them in particular, her name is Mar Avery. Her Twitter account is Data Me, and she got hired by RStudio because she got really good at sharing content made by others. And so she does a lot of, let me see if I can find a tweet. She does tweets like this, for example, where she takes a couple of screenshots from people, from stuff they've done, right? Like again, figures tell a story, right? So she highlights some of those things that she found interested in. She edits those figures and adds a source handle here on the bottom right, which takes a little bit of time. And then she highlights the Twitter accounts of the people that were involved. So this type of tweet gets a lot of other people engaged and stuff, right? And so she's a great content creator that you might want to follow, for example, on the R world. But yeah, I mean, we all start from somewhere, right? And there's many different ways that you can use social media to your advantage. Another one is that you might want to make online friends and then meet them offline. And so there's a particular Hopkins faculty member, Stephanie Hicks, that some of you already have heard about or even worked with. She and we actually became online friends before we met at a conference in 2014. And that's just one example for me, but like I've done this with like multiple people. And so the examples that Jeff provides here are like related to students and things like that. But let's say you're a staff member at Liber, and you might want to maybe you want to meet staff members, let's say Mount Sinai in New York, right? And they might have similar career concerns to the ones you have, and they could become great people to get to know, to bounce ideas off, and to learn also from their experiences and how they've, let's say, they are navigating their careers, right? And so I've benefited a lot from meeting people, making friends, and getting advice from them over the years. So that's a great motivation for me, and it might be for you too. There's one aspect though about social media, is that people can be very positive or very negative on social media. So if you're posting about like issues, let's say, for example, racism, feminism, economic inequality, there's going to be a lot of people that think on the extremes. And if maybe you want to be, or maybe you don't want to be the center of a lot of attention, right? So I don't post personally as much about those type of topics. Other people do. But then, like, for example, I've posted about like stuff about Mexico and the US here or there, and then you get like troll responses, right? People like in my case, because I'm from Mexico, people tell me like, go back to the country you're from, things like that, right? So that's, you have to think about what is the type of attention you want to get. And if you're mostly interested in other scientists, maybe just focus on that section, or other R programmers, let's say. But yeah, social media can be, you can meet nasty people that way, or nasty computer bots. Teaching science. So we will be doing this, and we'll be putting materials online for other people to access. We'll be putting videos online too, and that's part of why we'll be recording our journal club presentations, not the discussions, but the presentations themselves. And we could even write blog posts about some of our data science guidance sessions, if you're interested in scientific blogging, for some of the reasons we mentioned before. And so I like being quite open. There's more things you could do, like building a massive aligned open course website. That takes a lot of effort, and so we potentially won't be doing any of that. Books, I don't think any of us will be writing any books soon, except like some of the documentation and stuff that we use internally. And so that leads to the internal scientific communication chapter. And so we use Slack a lot and GitHub and other tools. And so I don't think I need to explain too much about this chapter because we're already doing quite a few things here. And something that is directly related to the chapter is the website that I'm building, because the idea of this website is that it's going to be a better, more complete version of the onboarding website that we had in the past. And it's also going to explain to all of us, like, we do some things, right? And it takes time, right, to build this website. So that's why we hadn't done it in the past. But hopefully we'll make it easier for new team members to join and get up to speed on what are the things we like to do. And that's because whenever we bring in someone, right, like, we're going to try to offload a lot of our knowledge onto them. And that can be very challenging because there's a lot of acronyms, a lot of things we've learned over the years, right, or even over the last couple of months. And I mean, Luis and Arta, who are newest members, have gone through some of this transition period, right, of just learning what are the things we're talking about. Scientific talks. So we'll practice some of this on our journal club presentations, but there's many different types of scientific talks. And actually, a very, very interesting point here is that sometimes you should make your talks to entertain, not to teach. And why is that? Like, depending on the venue of where you're presented, your goals might just be to meet people, to make people excited about your ideas or results, to make sure people understand your ideas or results. And then sometimes you just want to practice speaking, right? And so we'll be doing some of this, but the entertainment portion is a really interesting, like, that point of view, why Jeff argues that, like, it's maybe good to entertain. And so that applies more for a conference, but it could also be part of a journal club to some extent, right? You still want to explain about the ideas, things like that. But if the goal is to make people excited about a paper, maybe you also want to just entertain them about the paper or software instead of explaining every detail about the paper. So this is an interesting point of view about how to do things a little bit differently. So on a group meeting, right, maybe the goal of your meeting is to update people on what you were doing and to get help. And we might also have presentations like this, right, because we're going to have space devoted for people to ask questions that they need help with. And so this is something that the ideal presentation should include, which is a small introduction to the problem, some updates of what you've tried, but then also have a lot of space for discussion about what you're trying to do next, right, or where you need help. And this short introduction to the problem gets really complicated, right, because sometimes you want to explain every single thing you've done, and then it no longer becomes a short introduction. It becomes a very long introduction, right? And so we've all done this in the past, and this is something that we need to think of the next time we're asking for help. How can we entertain others, right, such that we can get help from them? What is the minimal information they need? So there's a lot more in this chapter about scientific talks that I'll let you guys explore more in detail. We're near the end, so reading scientific papers. There's many reasons why you might be interested, and there's different types of journals. Many different reasons why you might be interested in reading papers, and also many different types of journals. So Jeff here highlights some of the broad categories of scientific journals, and then what are the tools you can use to try to find them. Now, here I would say that this section, like what are the papers you want to read and journals and all of that, will really depend on what are the things you're interested in learning more, right? And so this, I think, is, if you decide to make a social media account, I think here the question becomes more like, who are the creators you want to follow, right? Because maybe you identify creators that are already identifying the knowledge that you're interested in. And let's say we found that tweet from Maverick, right? And we're like, oh, that's a great thing. Like, that looks really like something I want to learn more about. I will typically include a link here, right? And so this link in this particular case leads to a website about a contest, and it's going to take a bit of time to read all of this, right? And so at this point is in a way the equivalent of reading a scientific paper, but you're reading like a more technical description of an event of interest in this case. So yeah, curators for your social media science, I think, actually overwrite a lot of this stuff about the different types of journals and things like that. I used to have email notifications from journals like Nature and Science and other journals with specific keywords of topics I was interested in. But nowadays, I mostly just look on Twitter and see like what are things that people are commenting on, and if the people I follow on Twitter are people that have overlapping interests with mine, right? And so if I have multiple people that I follow on Twitter mentioning a particular paper, then that makes it easier for me to identify a particular paper or scientific event or software that I want to learn more about. So I think this section has evolved quite a bit about how do you identify papers to read. Now, how do you actually read them? So this is also about tools for getting the papers. We don't need any of this stuff because we have access to most papers through Hopkins. And I can show you some of the, there's a little piece of JavaScript code for your browser that will make it easier for that. Now, let's say you find a paper. So how much do you read? That's a great question, right? And so for me, like a lot of times it's I'm starting from Twitter, right? And so Jeff has this breakdown here of like 100% of the time he reads the title of a paper. Like 20 to 50% of the time he reads the abstract. 5 to 10% of the time he looks at the figures captions. And like 1 to 3% he reads the whole paper, right? And so I don't have any data on my own personal tendencies, but for me it's like 100% of the times I read the tweet. I mean, not the title, I read the tweet. And then sometimes I do look at the abstract of the paper, and then a lesser percent of the times, and then actually download the paper. And then at that point, I'll look at the figures. Why do we actually look at figures? Because figures are actually like how people highlight their stories. And so actually, a lot of times I might just look at a specific figure of the paper, right? And then from that figure of the paper, I'll try to find the methods and results related to that particular figure of the paper. And that might be all the things that I read. And a very small percent of the papers, I actually read the whole paper, just like Jeff. And so these are, if you know how people behave when they read papers, then this is also going to alter how you write papers, because you're going to try to make sure that everything on the figure is clear. And if people want to learn more, then they can go to the methods or the results. It's not how they're formatted. It's not how papers are formatted. It's not how they're presented to people, but that's how actually people read them most of the times. And so there's more details here about how to read those sections, how to interpret, how do you deal with the paper, and how do you deal with hype. Hype is such a big thing in our field, and that's because people are always pressured to say that they've done something great, that they've had a breakthrough, because they're like, oh, or that they're close to having a breakthrough because they're just going to use the paper as a way to secure more funding, right? And so this gets tricky, and I think that like really the only solution for this is to have more experience, right? To read more papers in order to have a better way of valuing whether what someone is writing is too much hype, or does it seem like it's grounded in reality. And so something that is actually very important with reading papers is to explain them to someone else, because that's how you can make sure that you're understanding the core concepts of a paper. And that's also why we're going to have a journal club. The section about find if others have read it, that's basically where I start, from Twitter. A different way of checking it though is from the actually bioRxiv itself, or websites like that. So let's look at, for example, at one of my preprints. If I look on bioRxiv, on their metrics, bioRxiv actually links to tweets people have mentioned about this particular paper. And so, well, here, I mean, this is some tweets that I wrote that got retweeted and things like that. But I can actually, like, here, for example, right? I clicked on her profile. Here we can find a tweet about someone mentioning this in the paper and what they thought about it, right? And so sometimes you can learn a lot from what people are tweeting about your papers or other people's papers and stuff like that. So they might share whether they think this is a good paper or not a good paper, right? And so based on your opinion of that person, you can also that person and other people then you can start to build also your opinion too, right? We'll get a little bit of a feel of what everyone else thinks about the paper. Credit, again, this gets a bit complicated, and like some of you might not be as interested in credit as others, right? But one of the things you can start to do is actually to quantify everything you do. So that leads, for example, to how many stars you have on a GitHub repository, how many downloads you have for a particular package you've made, and things like that. But this is a lot more focused on a PI career, for example. So some of you might be interested, some of you might not be as interested in that chapter. Career planning, I'm going to skip because that's the chapter that I've explained a bit already last week, and that I ask you to read more carefully before we meet for our career planning sessions. So that leads us to the last chapter, which is about your online identity. And so this is something I've struggled a lot with Jeff's advice, because he, for example, says have a standard handle, right? And so I had my own standard handle for a very long time, even before I was a PhD student. The problem is my standard handle was not really related to my name. For example, Jeff uses JTLeak as his standard handle, and my standard handle was Felgernon, which is a random name. And so I have a lot of mixed feelings about this. I do agree that you need a standard handle, but whether your standard handle has to be something that is your name or not, well, that depends. And there's people that are really very famous. I was just mentioning, for example, Mara. Mara has her handle is Data and Me, which is not her name, and she has like 45,000 followers, right? But a lot of people like to use initials that are related to their names and last names. So I actually just changed mine to make it more consistent, between Twitter and GitHub and Gmail, because I guess I've been slowly transitioning away from Felgernon into my GitHub username. Something that is really, really important is this one about don't be a jerk. And so if you're using anything online, people on the internet will see it, right? He even mentions your mom, for example, being able to see what you do online. I don't think my mom has seen it online, but this has actually helped me a lot. So in the past, I would sometimes complain online, and I received the advice to try to do that less. And I think that has helped me, because I mostly try to share the positive things, or the things that excite me, or news developments. And so I try to be constructive. And so Jeff actually mentions this also here in the next phrase, right? You want to have constructive contributions. And so I've been told now by people that they like what they see of me on Twitter, for example. They like how I try to give credit to everyone else that was involved, or people that I'm getting resources from. And so the hard part is whenever someone else is a jerk to you, right? That's when you maybe be tempted to respond in a similar kind of way, but it's best to avoid responding. And so even though Jeff has a whole section on his book about using blogs to respond to criticism, some of those thoughts apply also, for example, to social media and things like that. How do you deal with negative feedback? Cool. So I think by now, you have a pretty good idea of what is covered in this book. And I'm going to stop recording.